All right, today we're going to be naming and finding angles. All right, we're going to start off with the diagram on the top of page 37 that looks like this right here. All right, we'll start off with some names names. Names for, we're going to say angle 1. Some names for angle 1. Anybody want to give me a name for angle 1 up there using vertices or using points on the angle? Angle, say again? ABD, very good. And one more name for that angle 1. DBA, good. Angle DBA. Okay, when you're describing an angle, the vertex of the angle always is the middle letter in the description. All right, so in this case you can go A, B, D, or D, B, A. Some names for angle 2. Yes?
So the middle letter would be vertex.
Middle letter is always the vertex. Angle 2. Get someone name angle 2 for me, please. CBD, good. Another name for it. For angle 2. DBC. Another name for angle 2. How about KBD? Still talking about the same angle, right? Another name for angle 2. Yes?
LBD.
LBD, good. Angle LBD. Alright, so you use a point on the side of the angle, you use the vertex, and you use another point on the side of the angle. Let's go to angle 4. A name for angle 4. No, I mean 4. Addie, a name for angle 4. Good, angle KCE. And one more name for that angle. Casey. ECL, good. Very good.
Please, ABD
ABD?
angle 3. No, KBD.
KBD? No, that's angle 2. Okay, interior and exterior of an angle. Let's put point F right here. And then we'll put point Q here and point R. A point on the interior of angle ABD. What's a point on the interior of angle ABD? Yes. Point F. Good. How about exterior of angle ABD? Somebody give me one. Casey. Q. Good. What else?
R.
Good. Point R. All right. This shaded region would be the interior of angle 1, wouldn't it? And everything else would be the exterior of angle 1. Yes?
What are the parentheses?
The parentheses there. Oh, these things?
Yeah.
The quotes? That means the same thing without rewriting the same thing.
Oh.
That would mean the exterior of angle ABD.
Okay. I was like,
Little way to save some time when you're taking notes. All right, any questions about any of that? Naming an angle. 3 letters, using the vertex as the middle letter.
Wait, is that a negative Q or a negative S? Or do an O?
Turn the page, please. Let's look at this drawing. All right, let's see. Copy the diagram below and extend each ray. Classify each angle as right, acute, or obtuse. Then use a protractor to measure. All right, we're not going to use a protractor to measure today, but we can estimate. And we can get really close by estimating. All right, so let's look at angle MJP. And let's classify it first as acute, right, or obtuse. It's right angle. And what's its measure? 90 degrees, good, because that symbol means 90 degrees. Let's look at angle NJP. Acute, right, or obtuse? Acute. And let's estimate its measure. 30 degrees, looks good. Angle KJN. KJN. Obtuse. Okay, this much of it right here, that much of it would be 90, right? NJP, you guys described it as a 30-degree angle. So what would this be based on what's up there? This would be another 60, wouldn't it? All right, using the numbers that you've come up with. So 90 and 60 is 150. How about angle KJP? What's it called? Straight. It's a straight angle. and it measures 180 degrees. Very good. Any questions there? Top of 39. All right, just as segments that have the same measure are congruent segments, angles that have the same measure are congruent angles. All right, so do you see the red arc marks? Okay, here's how that works. Any angle that has one arc mark is congruent to all other angles that have one arc mark. So you can say that angle ABC is congruent to, the symbol for congruent to is an equal sign with a squiggly line on top of it. Angle ABC is congruent to, what's it congruent to? Which angle? DEF, very good. And what do they both measure? 65 degrees, very good. All right, angle CBE is congruent to angle. What's CBE congruent to? DEB or BED, right? DE. F is not a vertex. Okay, F's not a vertex. Now, who can tell me the measure of angle CBE? Yes, sir. 115. Is that, how did you get that? 180 minus 65. Okay. Angle CBE is 115 degrees. Because look, just a minute ago, we said that a straight line measures 180, right? Well, if 65 of that is angle ABC, and the angle next to it helps it form a line, then it would be 180 minus 65 would give you the 115. How we doing? All right, so let's say this about this picture. If MNP is congruent to PNO, right? M, N to P is congruent to P, N, O because of the arc marks, right? They're congruent angles, they have the same measure. Then ray NP is an angle bisector. And that was in your definitions on Friday. A ray that divides an angle into two congruent angles, right? N to P, ray NP, splits MNO into two congruent angles. So it's called an angle bisector. Just like a segment bisector splits a segment into two congruent segments, an angle bisector splits an angle into two congruent angles. So if you were told that this top angle, MNP, was equal to 8x minus 13, and the bottom angle, PNO, was equal to 6x plus 11, all right, and let's say you're asked to find the measure, the lowercase script m, you're going to read that as the measure of, so find the measure of angle MNO. Find the measure of angle MNO. So in order to find that angle measure, what do you need to know first? You need to know what x is, don't you? And what do you know about 8x minus 13 and 6x plus 11? They're equal, because they're both representing these angle measures. So your 8x minus 13 equals 6x plus 11. So subtract 6x from each side. Two x minus 13 equals 11. Add 13. Two x equals 24. And divide by 2. So x is equal to 12. So how do you find each angle measure?
You plug X in.
Substitute, right? So 6 times 12 plus 11. What's 6 times 12? Plus 11? Okay. So this angle right here is 83 degrees. Is that what they're asking you for? No, this is when those highlighters come in handy. They're asking for this one. MNO. Alright, so if this side is 83 and they're congruent, this side's 83. So what's the entire angle going to measure? 166 degrees. Very good. Everybody caught up? Okay, don't don't write this down. Just watch for a second. I want to cover this. Somebody got confused last period. Let's say you got this. These are congruent. Look. And let's call this angle 1, angle 2, and the big one's angle 3. Okay, angle 3 minus angle 1 equals what?
Angle 2.
Angle 2, good. Angle 3 minus angle 2, minus angle 2 equals?
Angle 1.
Very good, angle 1. Angle 1 plus angle 2 equals? Angle 3. Okay? Everybody good with that? That's just angle addition postulate. All right? Now, what if you are just given angle 2? Given angle 2 and asked to find angle 3. If you're given angle 2 and asked to find angle 3. Exactly. So look, angle 2 times 2 equals angle 3, doesn't it? Because these angle 1 and angle 2 are the same. So 2 of this one equals 1 of the big one. And angle 1 times 2 equals angle 3, doesn't it? Okay? Yeah, or if it's an expression. Okay? If angle 2 is 4x plus 7, and I don't know, angle 3 is 120. And that's all you're given, and you're asked to solve for x. Wouldn't you do 2 times 4x plus 7 equals 120? Right? 2 of these are equal to 1 of these when these are congruent to each other. All right? When the two angles are congruent. Yes?
So if you have angle 3 and you're trying to find like angle 1, you use the
Yes. If you know angle 3 and you're trying to find angle 1, you could say that angle 3 divided by 2 equals angle 1, doesn't it? And angle 3 divided by 2 also equals angle 2, because 2 and 1 are equal to each other. Good? All right, well done. Your assignment for today is on page 42. Problems 30 through 42. And be sure to check the odds and headline. Check the odds and headline.